In this video, we will learn about the topic of variation, which is also called proportionality. There are three types of variation that we want you to learn in this class. One is called direct variation. So as you can read here, we say that there is a direct variation between variables y and x, or equivalently, that y varies directly with x if there is a constant with y equal to k times x. So the idea of direct variation is that if one of the variables gets bigger, the other one also gets larger, at least in absolute value. The idea is that they are proportional in that, going up on one makes the other one go up and so forth. That is the idea of direct variation. We will see inverse and joint a little bit later. For our problem here, it says for a non-salaried employee, the amount of a paycheck and the number of hours worked are directly proportional. If an employee earned $450 after working 20 hours, how much will their paycheck be if they work 30 hours? So they tell us that we have these two things and they're directly proportional. So let's let Y be the paycheck amount in dollars and X is the hours worked. So because they tell us they are directly proportional, that means we have an equation y equal to k times x. I do want to point out something here. Y equal to k times x, you could also solve for x and write x is 1 over k times y. Or in other words, if y varies directly with x, then x also varies directly with y. So what that means is it doesn't actually matter which way you set up your equation, which variable you call y, which variable you call x. As long as you are consistent with your choice, you'll get the right answer at the end. So they tell us one piece of information that it's $450 when you work 20 hours. So the paycheck is $450, the hours is 20. And let's see here, we should get 2250. Looks like that's what we should get. We do 450 divided by 20. So keep in mind what this k that we just solved for is. It's what's called the constant of proportionality. But in this real world scenario, that is your dollars per hour that you are earning. So it's the rate at which you're earning money in this case. So this k does have an actual meaning, but in terms of these problems, we're just solving for k to help us get the final answer. So once we know that k is 2250, then we can look at the second part where we know it's 30 hours. We don't know the paycheck. We do know the k. We do know the hours. And if we multiply this here, let's see, $675. And that would be how much they would earn if they were to go 30 hours of work that time. Okay, so this is our setup for whenever we have direct variation. The next type of variation is called inverse variation. And that is when we say y varies inversely with x. It's y equal to k divided by x. In this case, when your x variable gets larger, your y value gets smaller. And when your x gets smaller, your y gets larger. Once again, if you say y varies inversely with x, that's the same thing as x varies inversely by y by solving around here. So once again, it doesn't matter which one you call x, which one you call y, you will get the same final answer at the end. So the example I picked here, the time it takes to get to school varies inversely with the speed. If it takes you 10 minutes when traveling 60 miles per hour, how long will it take you when you travel at 40 miles per hour? So this is something that everyone driving every day could try to figure out, how much is their trip going to change by based on the different speeds they might travel on. So in this case, let's y be the time and x be the speed. Again, it doesn't really matter that much which order you put them in here. So if y equals k over x, then It says 10 minutes is the time if you are going at 60 miles per hour. Solving for k, we're going to get 600. Then the second part, we now know we're going at 40 miles per hour, but we don't know our time. So 600 is my k, my miles per hour is 40, and this time it's going to take 15 minutes to complete the journey. So changing your speed from 60 miles per hour to 40 miles per hour made your trip go from a 10-minute long trip to a 15-minute long trip. For the final type of variation that we're going to talk about, something called joint variation. This is when you have more than one variable that are all connected to an output variable. So in this case, you are not going to have just x and y, we're going to have x, y, and z. And z is going to be my output, whereas x and y are my input. And you can't so easily switch these things around like we did before, so it matters which way they write the sentence. So in this case, they say z varies jointly with x and y if z equals k times x times y. So it's kind of like directly in proportional with x and also directly in proportional with y. Now for the example, in physics, the kinetic energy of a moving object varies jointly with the mass of the object and the square of its speed. I want to point this out here, it's very important. We're not just going to have speed as our variable, we're going to have the square of the speed as the variable here. So for my equation, z is going to be the output, that's going to be the kinetic energy. The two input variables, x is going to be the mass, and y will be the speed. So it says z, kinetic energy, varies jointly, so it's k times the mass, x, and the square of the speed, so it's going to be kxy squared. So then for the first information they give us, it says a 10 kilogram object, so x is 10, traveling at 2 meters per second, has a kinetic energy of 20. So let's go ahead and figure out what k is here. That's 40, and k is going to be 0.5. Once we figure out our k, then we have the next piece, which says we are going to have a 5 kilogram object traveling at 4 meters per second. And let's see, that looks out to be 40 joules. That's the amount of kinetic energy. So even though the second object is half the size, 5 kilograms instead of 10, and on the other hand, traveling twice as fast, 4 meters per second versus 2, it actually has double the kinetic energy of the larger object. It's kind of an interesting fact about how things work in physics, is that when you're proportional to the square of the speed, that ends up being a bigger issue of what the kinetic energy is going to be. But regardless, no matter what specific example we try to have for these types of problems, we just follow the same steps like this, and you can get your answer. But remember, direct variation, y equals kx, inverse variation, y equals k over x, and joint, z equals k times x times y.